So that's tyramine. And there I don't even know why that's important. Epinephrine, she also mentioned you can also see tyramine in epinephrine. So that's your phenol. Okay. Like going over that. And I guess tyramine, another thing is hydroxy phenyl ethylamine. Why? Hydroxy, there's an OH. Phenol, that's a phenyl group. Ethyl 1, 2. Amine, so that's another name. Phenylpiperidine. That's just.
Where are you?
Oh,
never mind.
Yeah. Phenylpiperidine. So this is just talking about morphine has a piperidine in a phenol. So that's it. So morphine, this is kind of out of order, but morphine is basically on your third page. It doesn't have the dihydrofuran. If you take that part out, that's like morphine. It's missing that ring. Okay. So be able to draw that structure. I think by the end you guys will know how to draw. So Henderson has a bit. I'll go over that later. Okay. So stability. So morphine, it's unstable. Okay. It's usually unstable. So when it's in, let's see, when it's exposed to like air, so you have oxidation, right? The oxidation is going to. Let me grab my lecture. So oxidation will produce this 10-oxyl morphine. Where is it? Okay, so oxidation is basically gonna produce 10-oxyl morphine. So on 10th position, which is here, you get like a ketone. So that's why it's called 10-oxyl. Oxyl is like the ketone. Okay?
Yeah, oxyl.
No, second one, it's when it's exposed to oxygen or light, it's going to get radical. Just know the end product is a pseudomorphine, which is like two morphine together. When it's in acidic condition, like in stomach or something, basically the ring, the dihydrofuran ring, gets like cleaved off, right? So it looks something like a apomorphine. Okay? And then it gets like double bond here. It's not exactly the same as morphine, but no apomorphine. So that's slide 22 to 24. So know the three reactions that can happen to it and know the byproduct. Okay? I'll test that later. Okay. So as you know, morphine is an agonist. And later on we'll talk about the structure, how it becomes antagonist. So we just talked about it's like unstable, right? Like in acidic condition in air. So basically you want to use salt formation to stabilize it. Metabolism of morphine. So there's two main enzymes, 2D6 and 3A4. So 2D6 basically takes away the okay. So with that, we'll have to talk about codeine first. So codeine, the only difference between codeine and morphine is it has an extra methyl group here. So if you look at here, right, extra methyl group, codeine. And if you look at like okay, for example, hydromorphone and hydrocodone. So from M to C, right? Whatever that has C has an extra methyl. Same thing with oxymorphone and oxycodone. Where's your study guide? Here.
Can I teach you my trick?
From here.
Oh, sure.
Well, this is what Justin told me. So he was like, "Oh, codeine, it gets an ether, so it's got this bridge."
Yeah.
Yeah, he told you, right? Yeah. And then more, if it's got a more, then it's gonna have this OH. Where's the other more? More have an OH attached.
Yeah. So basically, when there's the C, you have the methyl there. Yeah.
And then what was the other thing he said?
And the other one would be the oxy and hydro. When it's hydro, it's H here.
Yeah.
Oxy is OH. Yeah. So that's.
This one is just this one I remember like butyl.
This one I remember like butane. That's why it's got the triangle. This is a comb for your locks. That helps you. It's gonna help me.
So it's really easy to differentiate. Okay.
And heroin Esther loves heroin. She does. That's why she's attached to it.
Okay, so 2d6 basically takes the methyl group on the coating off, so dealkylation. Okay. Here. 2d6.
And I have the
Okay.
thing.
So this is all dealkylation.
This is more confusing for me because it doesn't show the reaction. So I'm
Oh.
looking at the thing.
So basically, if you cross it out, it becomes morphine, and that's the coating is kind of like the prodrug. 3A4, it has N dealkylation, so the methyl group on the amine gets cleaved off. And she wants you to know after the CYP metabolism, you get oxidation. I mean, not oxidation. You get conjugation and glucuronidation. So that's a phase two reaction, right?
Wait, phase 2 is just glucuronidation. What about the conjugation?
Well, phase two is known as conjugation. Conjugation means adding anything to it. So glucuronidation, sulfation, that's all conjugation.
Okay.
So you need to have an OH in order to have glucuronidation. Okay. So the OH on the 6th position that could get can go through phase 2 too.
Okay.
Anything with the OH will get glucuronidation.
Okay.
And glucuronidation basically increase the charge so you can eliminate it. Are you recording?
No, I forgot.
Are you recording?
Yeah. I missed the first piece though. The
I was like,
you going
I forgot
over
I
it
told
more.
other people to do it.
Okay, so
My bad. Just don't know how I'm gonna get it off my phone to people.
no. Okay, so we just talk about the metabolism. So there's CYP enzyme, 2 CYP enzyme, and the phase 2 conjugation. So now the structure analysis. So, yeah. So basically, this one. So on the top, the OH on the 3rd position. That's important. If you take the OH off, you lose potency. So example, going back to this study guide, morphine and codeine, right? Codeine has the methyl instead of the alcohol. So codeine is less potent than morphine. Okay, now look at this one. Compare oxycodone and hydrocodone. Oh no, actually, compare hydromorphone and hydrocodone. Which one is more potent?
Hydromorphone.
Huh?
Hydromorphone.
Yeah, because that has OH, right? And if you compare oxymorphone and oxycodone, which one's more potent?
Which one?
Oxymorphone or oxycodone, which one's more potent?
Oxymorphone.
Yeah, see. In Dr. Chu's conversion table, hydromorphone and hydrocodone is kind of like the same potency, while oxymorphone is more potent. So this concept still applies.
Okay.
Yeah, but it's not as much as the third position OH. If you lose that, you lose a lot of potency. Another thing that's here, that's if you get OH group on like the 14th position, or any OH down there. Yeah.
Oh, yeah, increase.
Yeah, increased potency. So example for that would be oxymorphone and hydromorphone, right? So which one is more potent? Hydromorphone or oxymorphone?
Oxy.
Huh?
Oxy.
Yes. Okay. Oxycodone and hydrocodone, which one is more potent?
Oxycodone.
Okay. Yes. So that's how you see it. Okay. Another thing is there's this thing called oripavin functional group. Oripavin basically looks like
Oh, thank God! I was wondering what that is. What is that?
that's this. So what's this D thing? So this is oripavin right here. It looks like that.
Quite online. I couldn't figure out what it was. Oh, this thing.
Yeah.
Is it just this hex?
This is like the functional oripavin.
Oh, it's just that one group. It like has to have the 2 double bonds.
Yeah, something like that with like the O and yeah. I think it's this. When I look it up, it was that.
I was trying to look it up too, but it was kind of confusing.
But having that will increase the potency. I think that was in the lectures on here. So,
Oripaven.
Okay, so it's I saw on slide 10. So you know how this is dibaven and oripaven?
Oh.
Well, oripaven has the H there, but if you compare that and like other like morphine, the bottom group looks different, right? And when she was talking about oripaven, she was talking about she said the cells, right?
Yeah.
Cells. So when she said oripaven motif, she's talking about this.
Okay.
So that having oripaven motif here, that will increase the potency. If you lose the tertiary amine here, you lose the potency too. Okay, it's important. Anything that attached to amine, like the bigger the size, the more antagonist effect it has. So if you look at this third row here, you see all those like cyclobutane or cyclo.
The square.
Huh?
The cycle square.
Cyclopropane. Okay, you see all this? It's like big, right? Bulky. So if you look at the table, they're antagonists, right? And you should know naloxone and naltrexone. Those two, they're full antagonists, so they're actually antidote. They're the antidote for morphine.
Oh,
So if you have opioid overdose, those are the two antidote. Okay. Okay, so what else? I went over this one. Okay, and now if you just look at morphine overall structure, this part it's more. This is where the receptor bind.
Okay.
Whereas this part here is the selection, so it's specific, like which receptor. So she called this the address, right? Selection specific, like specificity.
What is the word?
Or selection, address. Receptor bind this one, and then there's a selection.
When you say selection, do you mean it distinguishes which receptor to bind to?
Yeah.
Okay.
So selection's on this side, but it binds to this side.
Well, this is like the paphilic, I think. I feel like this part is so like a molecule has to get attracted to the receptor, right? And then once it kind of get attracted to the receptor, it would check. It kind of see if it's the lock or something. That's
If it's a good fit, and that's
Yeah.
based on the address section.
Yeah. So that's the selection here. Right, and later on when you see like when you start taking out ring like the dihydromorphine, you start binding to more stuff.
This is.
Like for example,
It says.
morphine.
So when it's talking about the ether bridge, it says it increases potency. Is that what it's talking about? Or it's when? Oh, is it talking about the other ones, like with the OH on here, with the ether here?
Oh, actually, I didn't even see this here. Remove the ether bridge. I think
It is this one.
Yeah, I think it's okay. I didn't see this. Yeah, so well, remember that now. Remove that. You increase the potency. But okay, which is kind of weird. Okay, anyway, so what was I saying? Yeah, so if you take out this dihydromorphine, dihydrofuran ring, basically the molecule is smaller, so it's gonna bind to more. It's gonna lose the selectivity. So example would be later on. I'll show you. Alright, so she asked, which structure enhance potency? You guys know, right?
What do you want from Starbucks?
Can I get a Trenta ice cream tea? And I want 2 shots of, actually 3 of classic and 3 of raspberry.
Wait, 3 shots? I don't know what that means. 3 what?
3 pumps.
3 pumps.
3 pumps classic.
3 pumps raspberry. Okay,
Sorry, I
so
only know things that I order. Trenta ice, green tea, right?
yeah.
1, 2, 3, 7, that's
Okay. Anyway, so where am I now? Okay, so here, can you tell me which part of the morphine increased potency on this diagram?
This does.
Yeah. What else?
If there's an OH here that increases
Mhm.
potency, this increases potency. If you remove this, it increases potency, but it loses selectivity and.
Increased potency.
Yeah, that's what that says.
Oh, okay. I thought you said decrease earlier. Okay. Yeah.
So,
I
but
guess
it makes
increase.
it makes it easier to bind, but less selective. Yeah,
Oh,
you said
okay.
it's
That makes a
smaller.
lot of sense. Okay, that's fancy. Oh yeah. So, and what else? I think the sixth position OH is also important.
Okay.
Yeah. Okay. What determined the antagonist and agonist? Do you know?
the end.
Okay, whatever that's attached to N, the size of it. Okay.
Yes.
Okay, so
Bigger and tag. Bigger
yeah,
and tag.
bigger is antagonist. Okay, so I just went through all this. Tell me the three.
He's like, so you want 6 pumps? I was like, yeah, sorry. He's like, wait, so you really want 6?
Huh?
Yeah, in a Trenta they put like 10 usually.
Oh, really?
Yeah,
I
because
think the max
asked her.
is 7.
Oh,
They start charging me more when I go over 7.
Oh, because I got a Trenta with coconut. She was like, I was like, oh, can I get like 4 pumps? And I was like, what's the usual? And she's like, oh, like 8. What?
Well, if she likes you, she give you a lot of pump.
Oh, this is getting weird.
Okay, you're recorded, Kevin Wang.
Well, if you're interpreting stuff wrong. Anyway, tell me stability.
Oh.
Tell me the 3 when it's
So when it's exposed and it's
See,
oxidized,
okay, when it's oxidized, what compound do you get?
you get
I said no wonder he's like, I put 3 pumps classic, 3 pumps classic. So he's like, why did you just say 6? I was like, I'm so confused.
Okay, what do you get? Oxidation.
10 oxomorphine.
Okay. Okay, how about exposed to oxygen and air? What do you get?
Pseudomorphine.
Okay, how about acidic?
Apo.
Yeah.
Okay, what does APO look like?
It's really boggy. There's 1, 2, 3 rings like in a line.
Okay.
I know what it looks like, but
okay, if you know what.
Yeah,
it
like
looks
here,
like.
3 rings in a line.
It looks bulky because they drew the bottom ring.
I know, and not chair formation.
But
It's really more like a catechol. Like, you see this part? Which would make sense to me.
They
'cause
couldn't
it's
drop
for
the chair because
Parkinson's.
the aromatic. Yeah. But anyway, how about pseudomorphine? What does it look like?
It's like 2 morphines.
Okay. Okay, so she just wants you to know, like the amine, protonated amine is usually, the pK is usually 6.6 to 8.3. I will just minus 8. For the phenolic OH, which is top here, right? It's 9.3 to 9.7. I just minus 9.48. And the bottom OH is 13.5. So the reason why this OH is more acidic is because you have this aromatic here, and due to resonance, you can push electron around. So this is electron withdrawing group. So that's gonna pull electron this way. So this is more acidic than that. Okay. So that's 9.48. That's 13.5. So if she give you pKa, you know which pKa is which.
6.
Okay. Does that make sense? You weren't listening. Okay. Here, look at this. You have 2 OH group, right?
Yes.
This one has an aromatic. Aromatic has resonance structure. Basically, can push electron around. Okay, just know this is electron withdrawing group.
Okay.
When you have electron withdrawing group,
Oh, I heard that part. Okay, yeah.
electron get pulled this way. H falls off more easily.
Okay.
Right?
Yes.
So that makes it a stronger acid. So pKa is lower. Right?
Lower. Okay. Yeah.
Whereas this one, compared to this is higher.
Okay. How much higher?
This is 13.5.
Oh.
Okay.
So how come you have 9.48? Why don't you say 9.5?
Oh no, I just copied from her lecture.
Yeah.
You can round it up and down, doesn't matter.
Okay. Just like it's easier to remember. 13.5 and 9.5.
Oh. Yeah, I can. Okay, so tell me the 5 stereo center and the position.
5S, 6R.
5 what?
5R, 6S.
Uh-huh.
And then
9, 14.
9R.
9R,
Stop looking at it.
13S, 14R.
I didn't know it. I didn't
Okay.
memorize that yet. I didn't even look at that. I didn't know what it meant.
Okay, Barnes now. What is it? We just went over.
5,
Tell-
6, 9, 13, 14. RS.
Okay, cool.
R. I think I forgot one.
Well, you get the point. Let's see. So that's two. Okay, that's just 2 page. Okay, now. Okay, I already went over the metabolism around the 3rd page, but basically 2D6 and 3A4. 2D6 take out which alkyl group.
Oh.
Yes.
Yes,
N.
okay. And 3A4.
N.
And so O dealkylation and dealkylation. And now the talk about phase 2. Let's see. And she just kind of wants you to know some metabolite is active. Like the morphine 6O. So even though you attach a glucuronic acid here, that is still an active metabolite. And we talk about codeine and heroin, right? They're pro
Prodrugs
drug.
because they have the ester.
Well, heroin has ester. Codeine has what?
I thought they both have the ester.
No, only codeine has the methyl group, right?
No.
That's not ester. Ester is this.
Ether. Sorry.
Oh, right. Well, codeine is a prodrug because then 2D6. Is that 2D6?
Takes off the O.
Yeah, takes out the carbon
Yeah.
here.
Okay.
Ester is just like normal, like acid-base reaction can get rid of that.
Oh.
Okay, so we already went through that. So morphine structure. So morphine A, it's missing the dihydromorphine. Okay. Okay, but before that, let's talk about the PAT.
Oh, perfect. That's asking about this, and I was like, I don't know what that even means. I didn't see it.
Okay, so this kind of has to relate to the
What side is that? Sorry.
slide 39. But do you remember the amino acid sequence? Tyrosine,
Oh, tyrosine, glycine, phenylalanine.
Phenyl, okay. So TPA. So P stands for phenylalanine or phenyl. A stands for amine. T is tyrosine. So any of the opioid molecule, it has to have like this feature, like 2 out of 3. So
What's that PAT?
PAT, TPA, like just remember those 3 letters. Okay, so now look at morphine. Which structure does it have? What's this? That's a phenol.
Mm-hmm.
Well, I mean that's a what's that? It is a phenol, but this is a tyrosine.
C.
Right, so T. So that's your T here.
Okay.
That's your A here. So you have T and A.
So it's 2 out of 3.
Yeah, and then if you look at fentanyl, where's fentanyl?
On the top.
Oh, yeah, I don't think they.
Oh no,
dropped
they
it.
didn't.
Right here, fentanyl is here.
The patch.
What does it have? It has the.
Phenol.
So that's the P, or I'll just call it aromatic, or P could be here too.
Is this?
This would be like the A,
Alanine.
like amine,
Okay.
or the tertiary here, right? So
Yeah.
P and A, but it's missing the T, right? T is basically with the OH.
Yeah.
Yeah, so
Okay.
so it has P and A. How about this one? Oh, we just went over that, but
Alanine.
so A.
Will this still count as the tyrosine, even though it's?
Mm-mm.
No, but eventually it's gonna get turned into morphine, right? So which is the
Oh,
T,
okay.
right? That's why that's the prodrug. And codeine's activity, it's like if you look at the conversion table, it's pretty weak. It's like 100 compared to morphine. So it's like 10 times less active than morphine. How about this one? TPA, which one does it have?
Alanine. Is that an N? I can't
That's
see.
amine. Amine, right? So
Yeah.
that's an A.
And phenol.
Mm-hmm.
Phenol. So P, yeah.
Yeah.
P. Okay, so that's the TPA. So if you look at the amino acid sequence, there's the phenol and there's tyrosine, right? That's your P and T. In A, it's basically all this molecule has some kind of tertiary amine. Okay, so next one. Okay, so looking at those structure, right? Morphine A does not have the dihydrofuran, right? Next one we have benzomorphine. Basically, it's if you just look at this one, just imagine this as morphine. So this is like benzene attached to a morphine. So this is benzomorphine.
I just remember this one is just without the extra one.
Yeah, well, whichever that helps. This one you take the benzene off, so now it's phenol, right? So phenomorphine. This one it's that's a piperidine, right? On the left, and then it's attached to the fourth position of aromatic. So that's 4 aryl piperidine. Okay. This one here it's so remember aniline. Remember this is aniline.
Wait, I'm sorry. What's an arrow?
Aryl
Is that
means
just like
aromatic.
That's it.
Yeah.
Oh,
So-
okay.
So it could be, yeah. So remember this is aniline, right? Aniline, an H2 on aromatic, and if you put like a Mi or something, that's like a anidol or something. So this is 4 anidol. So you have an aromatic here attached to the Mi, right? So that's why this is anidol. 4 anidol. Piperidine attached to a piperidine. Do you get why this is anidol? It's that, right?
Yes.
Okay. Alright, next we have the butterfly. So if you see butterfly, you're on methadone, right?
Wait, I don't get it.
So we call this the butterfly motif.
Oh.
Yeah.
Okay.
And then I was just saying to help you memorize. Wait, I'm not sure. Do you like hallucinate when you abuse methadone?
I'm sure
Probably.
if you hallucinate.
Okay. So I was saying,
Nuts.
if you see butterfly, you're on methadone. And I think that's the only structure that have this template, which is the diphenyl propane amine. Diphenyl, 2-phenyl propane, 3-carbon amine. Okay.
These are my favorite kind when I can actually identify the thing by looking
And
at
you can
the
like reason them
structure.
out. Diphenyl propyl.
Okay. All right. Next one we have cyclohexylamine. So you just have a cyclohexane here, right? Attached to amine. Okay.
Oh wait, this analyto group, is it this whole thing? Or is it just this?
It gives it's like the whole thing. Honestly. I'm not sure, but I just know aniline is that. She mentioned that in class. So anilidol, I'm assuming just with the Mi on top. Yeah. But if that helps you memorize it. Okay, now I'm gonna test you guys. Alright, looking at the structure right here, which template is it? Without looking at. So just look for the functional group. What's this? Piperidine, right? What's this?
Phenylamine.
Aromatic attached to what? Mi?
Amine.
Which we just went over. Trina, stop cheating. Stop cheating.
I need to see it because looking at your squiggly drawing is not helping me.
What is that called?
But don't say the answer.
Oh,
What's aromatic attached to Mi?
phenyl. Oh, that's the analyto thing.
Yes, so what's this?
The
4 and a little
Piperidine.
piperidine,
Yeah.
right? Okay. How about this one?
Can I see your structure?
Okay, how about... Do you see it? Don't look at just look at parts of it.
Okay.
That's how you. Okay, how about this one? Do you see it? Look for the functional group. What is it?
Same as this one.
Okay. Okay. How about? Okay. How about this one? Come on. You have to see that. Just identify the functional group first. What's this?
It's hard to tell from your squiggles. I don't know if that's.
Okay, what does that look like? That's an aromatic
yes.
attached to what?
Amine.
Amine, right?
Analido.
Yes. So 4-amino piperidine. Okay, what's this one right here? Which template is that? You know? Okay.
Yeah, I don't know how to.
Morphinane.
Yeah,
Okay.
morphinane.
How about this one right here? What's this?
Is that on one?
One ring here, and this is like open.
Okay.
Benzo.
Benzo. Morphinane.
Okay.
Oh wait, no.
This one, benzomorphin.
Yeah.
This one is actually pentazocine, right? So here, it's a benzomorphin.
Oh, see, it makes a difference because this could actually look more like. Okay, go ahead.
Well, just look for the functional group. That will help. What else? How about this one right here? And if you can identify my structure, you can identify any structure.
I know. I can't tell what that is.
Diphenyl.
Oh, just look for the. Right?
Diphenylamine. Something amine.
So what's that?
No.
Prophenolamine.
Methadone.
Yeah, methadone.
Oh, the butterfly.
Yeah. How about this one right here? Okay, well, I'll just show you this. Which template is that? Look for the.
For
function.
arrow.
Well, tell me.
Piperidine.
Okay, what's this? This is arrow. What's this?
That's just a ring, actually.
That's just a ring.
Cyclohexyl.
Yes, and that's amine, right? So,
Oh, yeah.
cyclohexane, amine.
I think it'll be easier on the test. We'll have the options to cross it out.
Yeah, well, that's, you kind of tested you on the assessment. Okay, but, like I was saying, when you start making structures smaller, it start binding to more stuff, right? Especially like this part, which is the
Okay.
address, right? So it start binding to like MMDA, serotonin, that. No methadone, the R isomer is 12 more times more potent than S. Methadone is R, more potent. You see it?
R is more potent.
Yes. And 12 times more. Okay, okay, what's this one right here?
That's for arrow. Piperidine.
Okay. Okay, and you guys already know fentanyl. Fentanyl is more potent, right? How many times more potent? So about like 100. And choose at 80.
Mm-hmm.
Okay, and PAT. So you guys know the PAT, right?
Mm-hmm.
Okay. So I think we're good. I think you guys can identify all the structure?
Yeah.
Okay, so if you look at this, that's A, that's P. A, amine, P, A. So they all have the TPA or PAT. This one, this is like straightforward.
Yeah.
Deterrence.
What's your time, Kevin?
9:47.
Okay. Now, let's go over the OPA. So this one, instead, just look for, they all have carboxylic acid.
Mm-hmm.
But aspirin structure is really simple to acetic acid, right?
Mm-hmm.
Ibuprofen, I think those are easy to recognize. The process just looks like more complicated, but they all have the carboxylic acid. So know the antidepressant, so tricyclic, 676. You guys know that, right? Okay.
Wait, I don't know that. 6. What do you mean 6?
So 6 carbon ring, 7 carbon ring, 6.
I just know it looks like an elephant head.
Yes.
The two are double bonded, yeah. I mean, but you know what I mean. They're
Aromatic.
yeah. Thank
Yes.
The ears.
So
Yes, the ears. That's what makes them ears, because you can make a circle in the center.
okay, so you have alkyl, aerial alkyl amine is basically talking about aerial is aromatic, right? So you have carbon and amine. Okay. No, this is propane amine, right? Decarbon with amine. So propane amine. Do you see it? Amine. 1, 2, 3. Decarbon. Naphthalene. I'm not sure if you guys have to know, but for your reference, naphthalene is T aromatic.
No. Yeah, we've learned that before.
Anticonvulsant. So this one is basically the 676 with urea or Mi, whichever you want to see it. 676 with the Mi or urea is basically that, right? So just memorize the Mi at the end. So this is your carbamazepine and carbazepine.
Carbazepine and what?
I can pronounce the other one.
Carbamazepine. Let me see.
Oxycarb.
Oh, it's like the same thing.
But it doesn't have the MA. Okay. What's the brand name for carbamazepine? I'm supposed to see it. If you know. Okay. Just testing Melissa. She looks confused.
I don't know that one. I don't feel like it's important.
Well, that is for what do you use that for? Carbamazepine.
The trigeminal neuropathic pain or whatever.
Yeah. So neuropathic pain. Do you use that in fibromyalgia?
Nope.
That's one of the choice, right? Anticonvulsant. Is it?
Yeah, but which one? I'm talking about the ones that are clinically beneficial. Like.
Oh.
So no, I wouldn't use it.
Let me just double check. She had that weird. Oh, that's good.
I don't even remember seeing that one on there though.
You're right? Trigeminal something.
I think you're thinking about cyclobenzapine. Because there's this one. There's not the other one.
Well, I don't know. I thought they had it here.
Alright, these lectures are the ones I know the best. I don't know parenteral and stuff like that. You're looking at you're talking about the pain one.
Yeah,
the pain one of that one.
Okay. Here, so you guys know what's dibenzoazepine, right? 676 with the Mi.
This one?
Yeah, that's dibenzoazepine, and I think this is aromatic. It has double bond in there. So that's your carbenzapine and the oxy. So she put no, it's GABA derived compound. She put diverse structure template. I think she said at one point this is just for reference, but just in case, here's the structure. So 5-phenyl triazine, triazine, phenyl. This is lamotrigine. Okay. If you have a pyrrolidone, which is this.
Oh, I did write that. That is lamotrigine.
That's levetiracetam. And topiramate has this pyrrose. So pyranose is this kind of 6-member ring with the O. Okay. What else? Okay, for antiarrhythmia, lidocaine, you should know. Basically, it has the tertiary amine and the phenol, right? So tertiary amine and my phenol. So what's PAT? What does it have?
Hi guys.
Hi. So PAT, which one does it have?
Phenol.
Lidocaine?
Lidocaine.
Yes.
How will I find it?
And alanine.
Wait. Do you get it? PA.
It's
What
got
does
an
A?
amine.
What does A stand for? Amine, right? Does it have an amine?
Yeah.
Yeah. So that's your A. What's P? That's your
The ring.
like the benzene, right? Benzene ring. So that's your P right there.
Oh.
And then tyrosine is gonna have the OH on the benzene.
I didn't get it.
So if you get OH, that's T, right? Okay. Okay. If it helps you guys, I memorized lidocaine. So remember like aniline has the NH2 aromatic, right? This one kind of have a MI. So lidocaine. Okay. So just memorize those compounds. Capsaicin, just know it has the vinyl group with the 9 carbon and amine.
Chili pepper.
Yes. So it's pretty long. Right. Alright, so this thing is kind of... Okay, so we're going to go over this later, but TC99M, no, I would know it's 140 keV, the energy, and half-life is 6 hours. This is significant because 140, it's kind of like a low radioactivity, so it's easier to like shield, okay? So that's actually one of the advantages. 6 hour for a radioisotope that has like, so you have your radioisotope, like an element, right? And you have this with the M here. So this is like hyperactive state. And the hyperactive state usually goes back to the element state, right? And release energy. So on the periodic table, for this to happen, the half-life is usually like really short, like in seconds. But this is like, for TC99, this is actually 6 hour. So this is significant because you can actually give this to patient, and within a day you can use it for diagnosis, and you're not running the risk of over mutating their cell, right? So make sure you know it's 6 hour. So TC99M, if you see phosphate or phosphorinate, that means it's gonna bind to bone. Okay.
Okay.
And know which bone structure it binds to, which is hydroxy apatite or something. I don't know how you pronounce that. So know that binds to phosphate. Okay, which structure does phosphate bind to?
Hydroxyapatite.
Okay. 18F fluoride. Here it says you can also use it in bone. Just know this is PET scan. Okay, PET scan. Positron. Strontium, beta minus, blah, blah. You can just memorize on your own. For zyconotide, this is easy to recognize. It's basically amino acids. So when you have amino acid, it gets cleaved by protease. So you guys can read over that. Okay, did you go over the training question?
No. Kind of, but no.
Okay. Let's see. You didn't mark the answer, did you?
No.
Okay, that's good. So first, what's this structure right here?
Morphine.
What's that?
Oxycodone.
Okay,
Oxycodone.
good. Right? Oxy.
Codone, double bond. I mean ketone.
How about this one?
I don't know. It's a TCA, but I don't know which
It's
one it is.
dyspiramine.
Right?
Yeah.
I didn't memorize. I don't.
It's a TCA.
But that's good. You memorize. Yeah, it's TCA. How about this one?
Fentanyl. Because it's got a patch.
Oh, this
What's
is
the
the
template?
arrow.
Yeah, what's the template for this?
Phenyl, arrow, pyridine.
No, what's this?
It's for
aromatic?
Arrow,
Oh, wait.
pyridine. 4-arrow pyridine.
Are you sure it's not anidrol?
Oh, it is.
Yeah, it is. For analytical pyridine.
No, fuck
Okay.
my life.
That's right. Look at the functional group. Aromatic, mi attached to aromatic. That's anidrol. Okay. So which one of this will interact with opioid receptor?
Based on the morphine template.
No. Ignore the question.
He's
Just answer
asking
my
which
question. Which one interact with the opioid receptor?
A and
And D.
and D.
Everything react with
And
opioid
C.
receptor. Why?
Pat.
Because they'll have 2 of the pad, right?
Oh, they have to have at least 2 of the patch. I thought they had to have 3.
Oh no, like morphine only have 2, right? That's
Checked.
T. That's A. It doesn't have P, right?
Yes, it does. Oh, no, it
Right.
doesn't.
No, right? This one has.
Oh, wait, P, it has to be a benzene. It can't be
Yeah.
just a ring.
Yeah.
Okay.
Wait, I'm confused. This is a
I thought it-
benzene.
With the.
I thought P
OH
was just a
attached to it.
ring.
So that's a.
It
phenol,
has to be
right?
like
So that's like tyrosine.
benzene, like by itself, like
Yes.
this benzene.
Yeah, like aromatic. Yeah, so
Let
that would
me
be a
check
P.
this out.
That would be a P. That would be A. That would be a P here, right? And that would be A.
I'm gonna program my phone so that all my fingers work.
What slide is the PAT on? Tell me.
You know that Dr. Jacobs emailed us individually our score and what we got in the class?
You must have a lot of time. Okay.
Actually, not, because he does that, well, when he was a course coordinator. If you took your exam at a different time, he would email you your grade.
Oh, so nice.
Well, you guys don't have that much people in the class, right?
That's a good handful, I thought. Okay, P is a ring. A is T is.
Okay. So
Go ahead.
now, which one is based on a morphinase template? That's easy, right?
A, B.
Mm-hmm.
Okay. Now this what template is that?
Benzo.
Ben's
Yeah.
Morphia.
Benzmorphin. Okay. Okay. Let's answer this question. A. So is this correct?
No, because it can
Semi.
be found in phenol.
Fentanyl,
Fentanyl.
and morphine, right?
Mhm.
It can be found in morphine.
Morphine, but not
Okay.
fentanyl.
How about B?
False. Pentazocine does display a benzomorphine, but that's not its structure.
Yeah. Well, I don't think she expected to know specifically. So when I saw that, I was kind of questioning.
Holy shit, me either. I was like,
Yeah.
I had to go look it up. I was like,
Okay. How about C? And tell me what's the pKa about you. You should know this.
benzomorphine?
Yeah. Look. Okay. Which?
It's gonna be higher than 4.
that's what I
Okay.
think too.
What's that? What's that here?
It's N, so it's basic.
And mean, right?
Mm-hmm.
And what did I say about mean? It's usually around what?
8.
A. Yeah. There you go.
That was a guess.
It's A. It's not guess. Your brain remembers it. Okay. How about this one?
No.
Does it have pyridine?
Yes.
But how about analytical?
No, because that's with the amino group.
Because if it had
Yeah.
that,
None of the
then
above.
Yes. See, that's why it's important to recognize the. Okay. Okay, what's this structure right here?
fentanyl
Okay, what template is that?
for analytical pyridine.
Okay, what's this right here?
Butterfly.
Okay, now let's look at this. Is A correct?
Yeah.
Is
Yeah.
B correct?
Yeah.
What's B?
Methadone.
Mm-hmm.
How many times more?
100.
12 times.
12.
Or is 12 times more
You're
potent?
thinking.
You're gonna snap me.
Fentanyl.
I saw you, Kevin.
You're thinking of fentanyl. Okay.
Oh, fentanyl to
Morphine.
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 How about this one?
Yes.
True.
Yeah.
The R isomer is higher.
Yeah.
So it's all of the above. D.
Okay. All right.
Aid.
Oh, lovely.
Let's see.
We done already.
All right. I'll go over this right after. This is easy.
Really?
Just like, oh,
We just kind of
save
have
my
to
life
memorize.
I'm excited that you think it's easy. This is
Me
good
too.
stuff.
Okay. Here.
My shoulder.
Okay. So there's radio. Well, you guys know the definition, right?
Sorry, I just kicked you.
It's okay. Radionuclide and radioisotope. Basically, the whole concept is from unstable to stable and release energy.
From stable to
Unstable
unstable.
You
From
change.
stable, and it gets stable when it goes into your, like the transition state into
So-
radiation.
Yes. So unstable is higher energy. That's why they're unstable, right?
Okay.
When it goes back to stable, it release energy, which is radiation. Okay. And you guys know radiopharmaceutics for like pharmacy, right? For treatment and diagnostic. I'm not sure you have to know this, but just know, at least know Curie is a lot more than one BQ. Okay.
What is it called?
Becquerel. I don't know. I'll pronounce it then. I don't know.
I don't know how to pronounce it either.
Okay. So just know that one has more energy than BQ. Maris is table. She said that's on the test,
That
But
one's not too bad.
but it's pretty straightforward, right? Diagnostic is short half life, right? You don't want it to be mutating patient's cell for too long. Okay, therapy is long
Okay.
because you want to be cytotoxic. Maris beta plus and gamma for diagnostic, and this one is beta minus and alpha. Do you have an acronym for this?
Wait, sorry. Say that again.
So for the decay mode, do you have an acronym for this? To memorize it? This one's beta minus and alpha. That's beta plus.
Bah. I don't know.
This one has AA. So, bam.
Okay.
Beta, alpha emitter, auger, beta minus.
Okay, just minus is like you're killing the cell, cytotoxic, right? Minus. You're subtracting cell. Does that make sense?
Yes.
150
Plus is like diagnostic. Well, this is just straightforward memorization.
Yes, it is.
And for diagnostic, of course, is detection, right? Treatment, you want high energy, right? Wait, can I? Let me get him. Oh, did I put money in this? Oh, I forgot.
You did.
I'll give him this. Okay, tell me the stability, instability for morphine.
Oxidation. 10-oxomorphine. Exposed to air. Then it's pseudo.
Air and oxygen. Wait, well, yeah, I guess. I think it's. I thought it was air and light. Is it? No?
So light is oxidation, right?
Wait, hold on, I think. No, hold on. Which one's the radical? I think that's the light. Air.
I thought
light,
air was pseudomorphine.
Yeah, but I'm trying to figure out. No, I should know this. Okay. Oh yeah, acid. Oh, that's right. It's light and air. Light and oxygen, yeah. And then the last one is acidic. Because light will introduce radical, right? Air is kind of like oxidation.
Yes.
But apparently there's
Not
also
the same.
oxidation. Well,
Okay.
it's actually the same, but there's two different modes. So this is Well, this is oxygen.
You have the room key?
Yes. Do they want me to open it?
Yeah, Christy wants the key to open it.
Who?
Christy is.
Who's Christy?
You
It's
know.
a P2.
Yeah.
Can I open it for him?
I want to see who's this Christy to make sure I can trust this person.
You already know who he is.
Which Christy? PT?
Like
Chris Diaz, not Christy.
Oh.
It's
Oh, yeah,
Chris.
Chris Diaz. Yeah, you can get the key.
So.
Oh my god, it's so dumb.
Well, I have to get the key back. No.
I'll get it back. I'll open it right
Okay, so the table. Memorize the table.
Table is, yeah, common sense. Okay, so you have the fluorine 18 FDG, right? FDG is fluorodeoxyglucose. So before I go over this, so I'm just gonna talk about how glucose get metabolized in brain. So basically, glucose get taken up by cell through like transporter, right? Like blood transporter, glue transporter, and then inside the cell, glucose get metabolized to like G6P, whatever,
Then it never
right?
leaves.
No, hold on. This is normal glucose. After it gets metabolized, the metabolite can leave the cell. Okay, it can leave the cell. But if you look at actually I need a glucose molecule. Oh, it's not even charging.
now. Oh, I'm shedding you that tampon.
No, it's the outlet.
I think it's this one.
Whatever. Well, plug that over there. See if it charge.
It probably will, because Mac is better.
Okay, yeah.
Google.
Plug it over there.
Go ahead.
You go ahead. Okay, so this is what glucose look like, right?
Oh, thanks. I didn't know what it looked like. I'm just kidding. I'm just kidding.
Okay, so you have position 1, 2, 3, 4, 5, 6, right?
Mm-hmm.
So if you take the OH from position 2 off, it cannot get metabolized,
Mm-hmm.
okay? And if that can't get metabolized, it will stay in the cell.
Ooh.
So let me just draw this out. So it gets accumulated in the cell. Okay, so this one gets metabolized, but this one doesn't.
It's the same thing if it's flipped up, yeah, instead of down.
It's just different isomer. So, there's like D-glucose and. But you don't have to know that. Just know the OH. Okay?
Okay.
No OH on second position, get trapped. Okay? So now how this fluorine 18 FDG works is they take a glucose without the second alcohol. Without alcohol on the second position.
Okay.
They put a fluorine here.
Okay.
Okay? And I'm not gonna go through how they make that, but they just shoot fluorine to this molecule until it
How do
attaches.
you do it?
Okay, and then so you have so if you have tumor in the brain, it's gonna take up more glucose, right?
Yeah.
So when the tumor cell takes up this compound in, you can actually image it. So that's how you diagnose. Yeah. So you use just remember this is positron emission. So fluorine's gonna release positron to become oxygen, right? Oxygen 18. So this radioactive molecule gets trapped, and that's how you identify the tumor region. And then you also you check over time to see if the tumor cell or the image region like decrease.
Oh.
So this one gets trapped, right? So you might wonder like if you trap a lot of this, is it not kind of bad, right? The fluorine it decay to oxygen, right?
Mm-hmm.
So now you have this thing. So after the half-life, it becomes this. Oh shit! That's.
Do we have to know these structures, or do you just know them for fun?
Oh no! Oh sorry. No, you don't have to. I'm just explaining the concept so you know.
Oh no, yeah, no, it does make a lot more sense. I just wanted to know if I should write them down.
But glucose, I thought you know glucose, right? Okay, so the fluorine, after the half-life, it becomes oxygen. So oxygen 18, still radioactive isomer, but now you have oxygen here.
Mm-hmm.
Hydrogen is gonna come here, and now you have an OH here. Now this thing can get it out of the cell.
Oh, okay.
Okay.
Oh.
So this process I just described. This is the Sokolov method.
So This is so much more helpful. Thank you. This sounds like English again.
Again? Okay.
Okay, actually, it never was English. You're right. This sounds like English now.
Whatever. So that's how they. So they trap the radioactive isomer or the compound in your brain, and then after half-life, you can get rid of it. Okay, let me just see this. So, cyclotron, it's the place where, maybe I should mention this. So how they make a F-18 is they have O18, oxygen 18, and they shoot a proton to it. So they shoot a proton, and that's gonna knock a neutron off, and that becomes a foreign 18. So if she just know this abbreviation. So OTNF, it means you use a proton to knock off a neutron, and you get F-18.
And this thing, when it, like you said, when it decays or whatever, that's when it like decays into, and the fluorine just knocks off, and then the O takes its place.
Yeah, it becomes awesome. So it's when this okay, that's too confusing. Okay, I'm gonna skip that. But no, this is positron emission. Okay.
Positron.
So what kind of scan is this? PET scan. You can kind of read this. I'm not sure that's important, but it's just saying like, oh, the positron hit the atom. Yeah. When a positron hits like an atom, it's split up into two particles.
And it goes in the opposite direction at the same rate.
And then it's like 511 cat.
Do you think those things are important? Because you said you have to know it for the other thing, yeah.
The 140, yes.
140, yeah.
Yes. But not. This is not important. I don't know. I just know you should know 140. Okay, let me just go through this. Glucose. So we talk about glucose in the brain. So local cerebral metabolic rate of glucose. So basically you're measuring how fast the brain takes up the glucose, right? And I just talked about Sokolov method. So you accumulate radioactivity, you trap. So hexokinase reaction, that's the enzyme that metabolizes glucose. And we talk about the position of the fluorine. It's on the second position.
So wait, this Sokolov method is like this changing to a glucose form, right? So it can get untrapped from it, or is it the fact that it gets trapped?
Yeah, trap and untrap. So here, you trap it, right? So radioactive accumulate. I guess you could say it's more of
the trapping.
Yeah.
Okay, I just wanted to make sure.
But that's the whole reason or whole method.
Thanks.
Okay,
Sorry, I'm just really trying to understand this.
Oh no, keep asking questions. You know, get it. So this is for metastasis for cancer and brain, blah blah blah. Okay, so PET imaging agent. So for this one, just know those three things you could do: glucose metabolism, myocardial hibernation, and more glucose metabolism. Well, because you're using glucose, right? Okay, blah blah blah. 70. I'm not gonna memorize this. Okay, next we have iodine 123.
Okay.
Just memorize this is spec. Okay, so anytime when you're giving a radioactive iodine to a patient, you want to give them potassium iodine. Because when you take iodine, it goes to your thyroid, right? So you want to give them a potassium iodine to protect their thyroid. So their thyroid doesn't pick up like too much radioactive iodine. Does that make sense?
Yes.
Unless you're trying to like purposely
hit the type.
Yeah. Okay. So first one we have iodine 123 iodine or something. But the way to memorize this and the structure is you can see a guanidine, right?
Yeah.
So that's the guanidine. So if you see guanidine, you know that's the I-123 MIBG, right? Okay. So again, this is spec. I'll know the indication is neuroblastoma and pheochromocytoma. Okay. Next one we have the 123 IO123 IO flu pen. This is easy too, because remember atropine has that tropane, right?
Mm-hmm.
So if you look at the structure, it has that tropane head, right? Remember atropine?
Mm-hmm.
So atropine associated with what? Dopamine, right? Like Parkinson's stuff, right?
Okay.
So this thing is used for to diagnose Parkinson's syndrome. So if you see IO flu pain, the PANE, that tells you it's for like Parkinson and also tell you what kind of structure. Do you see?
And what kind of structure it is?
Yeah.
Wait, so we need to recognize the structure of this one?
Yeah. Where's the?
Do you think she's gonna make her questions hard, Kevin?
Huh?
Do you think she's gonna make her questions hard?
I think it's gonna be straightforward. As long as you get the concept and
Okay.
those example, like it's not that bad because if you look at it, there's only like I don't know, 10 different compounds,
Okay.
and you can like for this like okay, we already know what FDG is for, right? Glucose metabolism in brain. Iodine is it's mostly for thyroid, but if you just look at the structure, this one is for Parkinson's syndrome. Okay, now moving on. Okay, iodine 131.
Okay.
So this one it's for thyroid function. So this thing is diagnostic and treatment. Okay. So you can actually treat hypothyroidism. I don't know if it helps. 131 is like a higher number. So that's for hyperthyroidism. I'm probably not gonna memorize the dose, but you can see. Yeah, I don't think you should memorize the dose. Okay, for this one, just know it's not for pregnancy or breastfeeding. Okay. And usually we have to wait like 6 months because before they could plan for pregnancy. They also have to check like pregnancy like.
So wait after
test.
6 months to get pregnant?
Yeah. And they have to use some kind of contraception.
Bless you.
Thank you. Okay, so okay, this is probably the most important one, TC99N.
Okay.
Okay, so here, the generator. I think she wants you to know how they make this.
Okay.
So usually when they order this, the manufacturer they'll ship in this generator,
Okay.
and I don't know, the physician or the technician makes it. It's basically you have this tube of column, right? Inside this column you have this this material, aluminum oxide. Aluminum oxide. So, okay, the reactant is MO99, right? So it's like in a form of fluid. So you pour the fluid down the column.
Okay.
So the MO99 it actually has a high affinity for aluminum oxide, so it binds to aluminum oxide. So as you pour the fluid down, all the MO99 binds to it, like that. And like over time, like when it goes through a half life, it becomes what TC99, TC99M. TC99M doesn't really bind to aluminum oxide, so it's gonna fall off the column. And whatever you collect down here, that's your TC99M.
Doesn't bind to aluminum, yeah, you said?
Yeah, aluminum oxide. So as soon as it turns into TC99M, lose affinity to the aluminum oxide, and it falls off.
So is it still in a liquid form then the whole time?
Yeah. So after you pour the fluid, right? You wait for a certain time. You use like some kind of solute. I think here they use sodium, some kind of sodium solution, and they just wash it out.
Okay.
Oh, here it's in 0.9% sodium chloride. Just kind of know the concept. Okay. Okay. Now TC99M. We kind of talked about this earlier. Know the half-life is 6 hours. This is one advantage.
Right.
The 6 hour is good because then like you can do the diagnostic test within a day. Okay, once it decays to TC99, so M is the kind of like the hyperactive state. Once it decays to TC99, TC99 is pretty stable. It has like a super long half-life, so that's it's kind of like safe, right? Blah blah blah. Half-life it's about 11. Blah, blah. Okay, and then you're just saying TC is a transition metal, so you can form all this different complex. Okay, and we'll go over the complex later. Advantage is cost-wise it's good. Blah blah blah. Carrier-free. So she wants you to know half-life is 6 hours. Low radiation, why 140 keV. Okay. Easily shield. And this is for spec. Like everything is for spec except the FDG, right? Which is PET. Okay. Okay, now we're gonna talk about different TC99M. Okay. We'll just get another paper. Okay, so first one you have. Okay, sodium. Let me just double check. What's this? So first one we have sodium I can't pronounce that.
Protectanate.
Protectanate. Okay, so protectanate is basically TC with 4 oxygen. Okay. So the structure is TC with 4 oxygen. So this one, since it has a negative charge, it's paired with sodium. Okay. But this compound, it targets the sodium iodine symporter and thyroid gland. Okay, so this one treat like thyroid cancer. Okay, and since it has sodium in its name, just kind of nice sodium iodine symporter for thyroid. Next one we'll have exmetazine. I don't know how you pronounce that. But this one, it looks pretty crazy. So HMPAO. Okay, basically it has like a lot of methyl. That's why it's like hexamethylene propylene amine dioxide. You guys should probably just like think of something to memorize that.
Memorize what?
For the HMPAO.
Okay. Oh,
I'll
hexamethylene.
just read the slide with these ones because these ones look like just straight. If you're memorizing the condition, yeah.
Yeah. Okay. Phosphate. When you see that, it binds to bone. Okay. And the MDP, HDP, and PYP. This is easy to memorize. MDP. So DP is like diphosphate, right? So you have two. I'm just gonna draw. You have 2 phosphate. In the middle, if it's connected by a methyl, that's M. M for methyl. MDP, right? What's next? HDP. So you have 2 phosphate. In the middle, if it's connected by a hydrogen, or the H is hydro, like alcohol group, right? That's H. So HDP. PYP is pyrophosphate. It's basically two phosphate together.
Okay.
So that's easy to recognize. C phosphate, you know, it's for bone. Next one, we have DTPA. DTPA, just memorize so PA stands for pentaacetic acid. Look for 5-acetic acid. That's the DTPA. Okay, so it's over here. 1, 2, 3, 4, 5. So that's easy. I think the only hard one is the HMPAO. And you have the MIBI, maybe. I can pronounce that. Okay.
Sestabi.
Okay, this one. Oh, this one's kind of weird too. But just know it binds to like 6. So it has 6 of this like weird functional group here. So just look for TC with 6 stuff attached to it. Okay? That's MIBI.
Okay.
TC6.
DTPA, look for 5-acetic acid. Okay? Phosphate, look for phosphate. The last one is lymphoseek. So lymphoseek is actually DTPA with sugar. So again, look for TC with 5-acetic acid. That's attached to sugar. And then the sugar is like really obvious. You're just gonna see a bunch of ring structure like attached to it.
Okay.
And since there's sugar, it mannose binding receptor. Okay, the last part, Etrian, like Y90 and LN111, or no, that's IN, Indian 111. So just know this is a monomer antibiotic. Okay, you guys can just read this. Just know the indication. If you're wondering what it looks like that.
Do we need to recognize the structures for these ones?
Like this one, I would say you don't have to recognize, because all the other radioactive, it has that molecule like TC. They all have the TC metal. Iodine, they all have the iodine. So this is gonna be obvious. I don't think she's gonna ask structure for that. So, okay, so let's do training question. Okay. So first, which are so A, radiopharmaceutics contain radioisotope with short half-life are diagnosis. Is that true?
Yes.
I think they're all true.
Okay.
Oh, low.
Why? Why is that? So radiotherapy
Should be high.
Yeah.
Yeah.
When you're treating something, you want high energy to be
Yeah, I know, that's
cytotoxic.
true. I was thinking this LET, like, because I knew it was linear energy, but I just saw this and I was like, oh.
Is that like a highlighter?
Yeah.
That's pretty cool.
It's supposed to be so you can see, like, where you're highlighting.
Oh. I guess only I'm impressed. Okay.
No, she already showed me and I was impressed that 2
Therapy.
years ago. No, I was kidding.
So treatment is like hours to days, right? So that's
Yeah,
easy.
that's
Okay, so number 1's easy. FDG. So A. Is A correct?
Yeah.
Wait, first, what kind of emission is FDG? Spec or PET? There's only one PET.
PET.
Yes. So that's
Beta
wrong.
plus.
That's wrong. It's positron emission.
I know it's positron, but it says beta.
Oh.
Beta plus. It does say beta plus. I kept looking at it thinking it said beta minus. I kept looking at it wrong. But I knew it was a positron emitter. I don't know why I kept thinking that.
Oh yeah, it's beta plus. Positron. Okay. So B.
Yes.
Yes, right? Okay. You guys remember the Sokolov? Okay.
This is obviously wrong.
Yeah, because it's not a spec, right?
Yeah.
So what's the answer? Huh?
B.
B? Okay, that's right. Okay. So, number 3. Thyroid can be extended by TC99N, sodium.
True.
True, why? What is this target? We just talked about that.
And thyroid.
Thyroid, which sim for it?
The sodium and sodium
Iodine.
iodine.
Okay. Okay, B.
This is true.
Yes, okay. Why is that? Why is 6 hour important?
Because it's used for diagnosis.
Okay, C.
Yes.
Why? Every time you see
Phosphate is
Binds
going to bone.
it binds to what?
The
What?
bone.
Which part of the bone?
Oh,
Hydroxy.
yeah.
Yeah, okay. D.
Yeah.
Pain, right? Pain.
Yeah.
And tropane. Tropane is for what? Dopamine, right?
Dopamine for Parkinson's.
Is this spec?
Yes.
Okay, so answer is see, it's pretty easy, right?
Yeah. Okay.
Thank you. That was actually.